Titration calculation. From a previous video on titration in practice, we ended up with the following data: sodium hydroxide 16.3 milliliters and acid of unknown concentration 25 milliliters. In this video, I will use sulfuric acid, and you'll see how to use this data to determine the concentration of the acid. First, let's put this data into the form of a typical problem. Given a standard solution of 0.108 molar sodium hydroxide, find the concentration of the sulfuric acid solution. We set up a table of titration data with these headings. Trial, 3 trials are generally done, the initial volume of the titrant, the final volume, and the volume that was actually used, which is the difference between final and initial. Here are the 3 trials. Here is the data from the first trial that we've just seen. The student has done a second trial starting at 5 milliliters. This shows that more titrant was added to the burette after the first titration. After reaching the endpoint, the final reading was 20.9 milliliters, which gives 15.9 milliliters as the volume used. Now the student has discovered that there's still plenty of titrant available in the burette. So she started titrating where she left off at 20.9 milliliters. Of course, she first discarded the previous titration, rinsed out the flask, and added a fresh 25 milliliters of acid. Starting off from where you left off is good practice, as it saves time and solution. The final volume was 37.0 milliliters. The difference is 16.1 milliliters. There is reasonably close agreement among these titrations. Ideally, they should be within 2 to 3 milliliters of each other. If a titration has gone bad for whatever reason, you just do another one. There's no limit to how many you may do. The idea is to get 3 titrations that give results as close to each other as possible. This gives good precision. The average then is taken and found to be 16.1 milliliters of sodium hydroxide solution. I'll go to the next slide and keep the data here in front of us. Calculations. First, we must write the reaction between sodium hydroxide and sulfuric acid. The products are sodium sulfate and water. And of course, you must make sure to balance the equation. We have 1 sodium on the left and 2 on the right, so we put a 2 here to balance the sodium. If you look at the hydrogens, we have a total of 4 on the left and 2 on the right, so another 2 goes here. Now we're going to use the concentration formula. Do you remember what it is? An easy way to get it is just look at this concentration and write what it says. Concentration is moles per liter. Now replace concentration by capital C, moles by N, and liters by V for volume. So you don't really have to memorize the formula, just remember what we mean by concentration. Step 1 is to determine the amount of sodium hydroxide in moles that was used to neutralize the acid. Manipulating the concentration formula to get N by itself gives us N equals C times V. Substituting gives this, and then 1.739 millimoles of sodium hydroxide. The millimole unit may seem strange to you if you haven't used it before. The L for liters can be cancelled out, which leaves us with this unit of millimoles. Just as milliliters are better for small volumes, so millimoles are better for small amounts. This provides more manageable numbers with fewer zeros. However, you could change milliliters to liters like this and end up with moles like this. But watch that you don't miss a 0 by accident. You can continue this way and still get the correct answer, but I will continue with millimoles. The second step is to consider the mole ratio between acid and base. Since sulfuric acid is the unknown, it's best to always put the unknown in the numerator because that saves 1 step in the math. The ratio of sulfuric acid to sodium hydroxide is 1 to 2. These come from the coefficients in the reaction. Cross-multiplying gives sulfuric acid equals 1/2 times the amount of sodium hydroxide, which is 1/2 times 1.739 millimoles, which is 0.8695 millimoles. The final step is to find the concentration of sulfuric acid from the concentration formula, C equals N over V. That gives this. Notice how we can cancel the millis to leave us with moles per liter. Our answer for the concentration of sulfuric acid is 0.035 molar or moles per liter. And that's how the titration data is used to determine the concentration of an acid. This also works to determine the concentration of a base. In that case, the base is in the flask, and the acid of known concentration is in the burette. The indicator is changed to bromthiamyl blue, whose endpoint is the first appearance of yellow. This was shown in the previous video on titration in practice. But the data is used in the same way as in this lesson. Here are 3 questions to end the lesson. If the solution remaining in the Erlenmeyer flask after the titration were evaporated to dryness, what, if anything, would be left in the flask? You can pause here while you think about it. Small white crystals of sodium sulfate would be in the flask. Since the only products are sodium sulfate and water, and all the water is gone, you would be left with solid sodium sulfate like this. You can scrape the crystals out with a wooden splint. What is the hydrogen ion concentration of the sulfuric acid? If you said 0.035 molar, unfortunately that would be incorrect. Remember that sulfuric acid ionizes like this. So 2 hydrogen ions form for every single sulfuric acid molecule. Since the concentration of sulfuric acid is 0.035 molar, we must double the hydrogen ion concentration to get 0.070 moles per liter, and that is the correct concentration for hydrogen ion. Finally, here is a typical question for you to try. 20 milliliters of calcium hydroxide were neutralized by 10 milliliters of 0.100 molar HCl. Calculate the concentration of the base. You should stop here and come back to see if you got the right answer. And here it is. If you didn't get it, this may help. This ends the video on titration calculation.